All right, gang, we're going to talk about another collections type, the map type. There are two types of maps that we're talking about. There may be more, but the two that we could be talking about are hash maps and tree maps. The big difference between hash maps and tree maps is that in a tree map, the data is sorted because it inherits from sorted map, or that's an incorrect way of saying it. It implements a sorted map interface. Those terms will make sense after next week's lectures. So a hash map is not sorted, meaning that if you step through it with a for loop or something like that, the items seem to come out in a random order. They are not sorted by their key, which is what K stands for. Whereas a tree map is in fact sorted. So if you use a for loop to step through it, you get them. You get them in sorted order. I'm going to skip the hash map because I find that having things sorted when I print them out makes things look nice. However, I would expect that a hash map might be marginally faster, over the long term. But again, the differences in speed probably negligible. I don't know. Anyways, I like things to be sorted. I would use a tree map. I'm going to illustrate a tree map. So I believe we're on Lecture Q. NetBeans just froze on me. Let's try that again. Making a new Java application. Do so in whatever fashion you prefer. Lecture Q. I'm going to remove the package statement, but I do want a main class. And so just like an array list, when you create a tree map, you specify the data types that it can store. And just like an array list, the data types have to be classes, not primitive types. So if you want to create a tree map that has integers in it, then when you create it, use the wrapper class integer with a capital I, rather than just a lowercase int data type, primitive type. So why don't we just include import java.util.*. I believe that's where the interfaces are stored. And we're going to create our tree map. Now, since these implement the sorted map class, sorted map interface, I could create it like this, and this is what my example that I'm looking at currently shows. Oh, come on. New machine, new problems. All right, I could do sorted map, and then give it the necessary information. Excuse me for a minute while I just play with this idea. I'm going to I'm not really sure why I would do that when what it returns, what we are instantiating, is an example of tree map. So until I see a good firm reason to do so otherwise, then this is going to match this. What are we saying here? We're building a tree map. This is the key type, and this is the value type. Because what is a map? Other languages call it a dictionary. For some other languages, it's a mapping between keys and values. Like if you had a Spanish to English dictionary, you'd look up the Spanish word, rojo, and it would tell you the English version of the word, red. We can do that. Why not? Okay, so I'm going to call this Spanish. I don't want to make so that it takes too long to type. S2E. Oh, that's stupid. How about just Spanish map? All right. Let's set some entries into our so-called dictionary, into our tree map. We use the put command. Put method does that. So Spanish map dot put the word rojo, end quote, means, quote, red, end quote, semicolon. Spanish map dot put Blanca means white, right? So Blanca, end quote, comma, white, end quote, semicolon. Why not one more? Green. Spanish map dot put parentheses quote green. And whoops, what am I doing there? Spanish word goes here. Verde, end quote, comma, quote, green. And just to be silly, Spanish map dot put taco, end quote, comma, means yummy food, end quote, in parentheses, semicolon. All right, what can we do with our map? Well, say we wanted to find out the definition of a word. We were going to ask the user for a Spanish word and we would look it up. We could do that. Let's create a scanner. Let's ask the user, tell you what, we're just going to hard code, right, the word that we're looking at. So string word equals, or the Spanish word, SP word. String SP word equals, we're going to look up taco. We want to find out what the English meaning for taco is. So let's find out. And we're going to use get value. So let's get the key out. Well, we already know the key. This is our key. We could just call this the key, but it is the key that we're going to use. The key is the word that we would look up, the value that we would look up, and then the value is what gets returned when we look up that key. So string value, or string of English word, equals Spanish map dot get underscore value, parentheses in parentheses, and I'm going to be looking up the Spanish word. Now, this is not going to compile. It's going to give me an error. The reason why is that even though we told it what data type the key is, the compiler doesn't really know that .get is going to be returning a string and that it's compatible with that. So we need to cast it to a string. Right? There we go. I'm going to get the error to go away. .get wasn't get value. I was looking at something else. So get, and then we pass in the key, which is SP word. Let's get another word out. String en word 2 equals, and we got to cast the results. So parentheses string Spanish map dot get parentheses quote. We're going to look up the word rojo. Let's just print those two words out. System.out.println en word, comma, or plus a space plus en word 2 in parentheses semicolon. So when we look up by the key taco, we should get the value yummy food, and when we look up by the key rojo, we should get the value red. So I run it, and taco was in fact yummy food, and O was indeed read. All right. Now we know what a map is, right? It's a mapping between keys and values. So the syntax to declare is tree map, and then the key type, which does have to be a class type, so a capital letter there. And then the value type, again, it can't be a primitive type, it has to be a class type or reference type. Then a variable name equals new tree map. We could do the same thing with a hash map, but I like my data to be sorted. Let me show you what I mean. I'm going to use a for loop. For parentheses string key colon Spanish map. That's not working right. Let me pause it. All right, I flaked there momentarily, pretending I was in Python where the syntax is easier, as is often true for Python. We need to get the keys set. So dot key set, parentheses and parentheses. So for every key in the set, for every string, we're going to get that value. String value equals Spanish map dot get parentheses by the key. And then we can print them out. System.out.printf parentheses quote %s equals %s \n end quote. Now let's fill in our placeholders with the key and the value. And when I run it, there we go. It printed out our entire dictionary, our entire map right here. And they are in fact sorted by their keys. Whereas if we'd done a hash map, an unsorted collection, then they'd be not even necessarily in the order that you just inserted them. They'd be in really no order that we could predict. So insertions into it probably are faster. That would be my guess. You could Google up advantages of hash map over tree map and find out. All right. So of course you can correspond, values to values. Let's do something slightly more interesting than that. Like, let's define a class called book, and book contains an author, a title, and a number of pages. And then what are we going to have as our key? Is just the item number of the book, right? We have some kind of inventory program, and so we have item numbers for our books so that we can look them up by their item number. All right, so let's define our class. I'm going to be weird and just define it right here inside this other class. So it means it's accessible only inside main, right? So I shouldn't define it here. Really, all classes should go in their own files, but I've said that before. All right, so to make things easy, I'm not going to worry about encapsulation. So the title of the book, the author of the book, and the pages, right? But we might want to make a constructor so that we could set all three things at the same time. So book, parentheses, string title, comma, string author, comma, int pages. And in here, we're going to set this dot title equal to title, semicolon. This dot author equal author. Oh, come on. This dot author equals author, semicolon. This dot pages equals pages, semicolon. That's our class. All right, this wound up being a little bit too long, so I'm going to remove the spaces on the equal signs. I just wanted it to all show up, on the screen without scrolling. There we go. Let's create some books. We're still in main. And I really hope it didn't mess you up that I put this class inside this class. If it does, just cut it, make it a private class, and then, you know, paste it above everything else, right underneath your import statements. All right, let's create some books. Book B1 equals new book. This is, you know, Watership Down, end quote, by Richard Adams. And it's 567 pages long. Book B2 equals a new book, Java is Fun, end quote. And this is written by Sue Programmer, end quote. And it's 400 pages long, or 4,000, it's a big book. And then book B3 equals new book, pardon me. Sorry about that. All right. So the new book is Harry Potter and the Sewer of Oblivion. Kind of a weird book. Never read that one, huh? Have you? Well, neither have I. It doesn't exist. And it's by J.K. Rowling. Rowling, however you pronounce her name. It's a short read. She just published this as a PDF you can download. There we go. And again, I'm kidding. It doesn't exist, right? Okay, so we have 3 books. Now we need a dictionary, a sorted map, that we can use to hold all that. So sorted map. Our key is going to be an inventory number. So it's going to be an int. Our value is going to be a book. So sorted map, angle int, comma, book, end angle, equals new sorted map. Why am I calling it sorted when it's a tree map? Excuse me. Sorted map is an interface. I cannot instantiate it directly. Okay, so tree map equals new tree map. Right. Now let's add our books to it. Oh boy, what are we getting here? Not a statement. Semicolon expected. What have I done wrong? All right, that was a dumb mistake. I didn't give it a variable name. So books, right? That's what these are. Books. It's the name of our variable. Now what? Oh, I kept saying you cannot use a primitive data type. There I go, using a primitive data type. Integer. Had to use a class type. Good illustration of that error. Guaranteed that'll be an exam question at the end, right? Can you use primitive data types with array lists or with tree maps? And the answer is no. Alrighty, let's put some books in there. Books.put. I don't know why I autofilled that. Let's say that inventory number 1, 2, 3, 4, 5 is book 1. Books.put, you know, 2, 3, 6, 6, 5 is book 2. Books.put 3, 4, 3, 3, 0. I'm just making these up. Comma B3. So we have 3 books in our dictionary. The keys have to be unique. The values do not. If I put in a different book with the value 1, 2, 3, 4, 5, let's make one more book. Book B4 equals new book. You know, this is just C spot run, end quote, by Bob Roberts, end quote, comma, 20 pages. There we go. And then we put that in, books.put as 1, 2, 3, 4, 5, comma B4. We have actually replaced that entry into the map. Right. So unlike an English dictionary, or you know what humans consider a dictionary, where you could have 3 or 4 or 5 different definitions for a word, here we can only have one thing that ties to the key. Each key has to be unique, otherwise it replaces it. And that kind of makes sense, because when you call .get and you specify a key, well, what would it be supposed to return? What should it get if we got 1, 2, 3, 4, 5? Would it return the first one we put in? Would it return the second one? Would it somehow miraculously return both? Like an array? No, not it. When you put in something with the same key, it overrides it. All right, let's print our books out. So for parentheses, book, key. Well, no, that's not right because our key is of type integer. Integer key, colon, books dot key set, parentheses in parentheses in parentheses, semicolon. No semicolon there. All right, remove that semicolon. Curly braces. Now let's get that value. All right. So book value equals, we got to cast it to a book, otherwise the compiler will not compile. It doesn't know what .get is returning. So books.get by the key. And we could print it out, right? System.out.println parentheses quote %d for the key, %s for the book title, %s for the author, %d for the pages, \n, end quote, comma. Let's print the key. Let's print the book title, value.title. Let's print the author, value.author. And let's print the pages, value.pages, in parentheses, semicolon. What are we getting wrong here? Because that's a printf statement, not a println. All right, that should work. Notice that even though we declared the key to be an integer, we're treating it like it's an int. Let's do something called boxing. If you have something of type int, then if you try to, of type integer, and you try to store an int in it, the compiler is smart enough to wrap it up into an integer object. You could do this, new integer, parentheses, right? Like that. Because that's technically what it's doing behind the scenes. It's when we passed in 1, 2, 3, 4, 5 like we did up here. The compiler is substituting the code, new integer, to create an object of the wrapper class. And it's crossing it out here. Wonder why? Probably because it's completely redundant. It will compile though, won't it? Yeah, all right. But that's silly. And yeah, the sample code that I looked up on the internet actually shows creating the wrapper type, but it's not necessary due to boxing. And the same is true, unboxing. If I have a value of type integer, but a function is expecting an int, it gets so-called unboxed, right? It converts the capital INTEGER, it converts the wrapper class to the primitive data type on the fly so that we don't have to. Works like magic, so we don't even really have to think about it. Here we go, let's run it, and we should see our book list. Here's our inventory. 3 books. As promised, 1, 2, 3, 4, 5 got replaced. It's no longer Watershed Down. It's C Spot Run by Bob Roberts. Okay. What happens if we try to get a key that does not exist in the tree map? Let's find out. We're going to get a new book. Book, I don't know, B5 equals, got to cast it, book in parentheses, books.get parentheses, and let's give a key that we know does not exist. 44444 in parentheses, semicolon. We're not going to like the results. When we run it, oh, did it return a null? At least it did not generate an exception. But sometimes it's useful to find out whether we got a valid piece of data or not. And for that we use contains key. Right, so our inventory number, int inventory number, or just inum, whatever, equals 44444. Let's find out if it exists. if books, whoops, where's our parentheses? If books dot, ooh, right there, contains key. Parentheses, enum in parentheses, we could get the book out and we could print something about it, right? Else, we could do something else. We could prompt the user again, right? Say that book not found. Please check the inventory number, right? Something like that. System.out.printf parentheses quote %d or book %d not found \n end quote comma item, which is the key. And just for some sense of completion, I'm going to copy that line, paste it here to where it says print the book out, and it's going to say book found, right? Because if I changed enum to something like 1, 2, 3, 4, 5, it would indeed be found. But true enough, the book was not found. So we could write an application. Ask the user, enter inventory number or -1 to quit. They enter an inventory number. We look up that inventory number. We check to see if the key exists in there. And if it does, we do something with it. We might even let them change it, access it, delete it, something like that. What if you need to remove? What if you need to remove an element from a tree map? I keep complaining about JavaDoc not being installed. Apparently on my other machine that I normally do this at home, I must have downloaded the JavaDoc file from Oracle and then configured NetBeans to know where it was. I'm not going to take the time to do that now. So how do you remove an item from a tree map? Remove item from tree map. Should be called object, right? It's an inbuilt method of the tree map class. It removes the mapping of any particular key. So you specify the key and it deletes it. This book 1, 2, 3 seems to be, hotly contested inventory number. Let's remove that. Let's remove it before we check for it. We're going to change enum 44444 to 1, 2, 3, 4, 5. It should be in there. Oh, I'd never change that to enum. You probably noticed that. All right. So anyways, change that to 1, 2, 3, 4, 5. If it contains that key, we access it by the key. But we're going to remove that item. Books dot remove 1, 2, 3, 4, 5. I noticed this something just now that puzzled me. Apparently, remove is overloaded to have 2 different types. Oh, sure. Don't show it to me now. Books.remove. Object key, comma, object value. Removes the entry for the specified key only if it is currently mapped to the specified value. Well, I guess that's useful, right? We know the key and we know the value. We might want to do remove key, comma, value to make sure that that's a specific one we remove, which is pretty much doing the same thing as if it contains that key, then check to see if the value equals, the value. But why not just remove it by key, right? So remove 1, 2, 3, 4, 5. Now when we run this, it's going to say book 1, 2, 3, 4, 5 not found, even though we know it is. And that book is not found, even though we saw it up here. Let's type books dot, see a list of the other methods, see if there's anything else we want to talk about with regards to clone. Okay, sure, if we need to make a new tree map, based on the contents of an old one, so that modifications in a new one would not affect the original one. We could call .clone. If we want to create our own class and use that in a tree map, there may be additional things we need to add to our own class to get it to work. But we didn't seem to need that here. In fact, we did not have to do anything special to our class at all to get it to work with a tree map. It's interesting to me. Okay. I really think that that's about enough of that topic. We could try the same stuff out with hash map. Don't see any reason to do that. We could write some code that uses queues. I don't see why we need to do that, because you could look it up if you needed to, and you have the primary concept of a queue already in your brain. Except I believe that the PowerPoint talks instead about priority queues. Well, here they seem to be implementing a queue via a hash map. That's bizarre. Or they're just not going to talk about queues at all in this chapter. Right there it is, right there it is, right there it is. Right. Queue based on integers. You add things to it, it adds them into the end of the list. You get things from it, it removes them from the beginning of the list. You can check to see if something is in there by calling .contains. All right, I think that's enough about that. It's going to be about time to mention projects, so you can spend the last happy 4 weeks of your class working on projects. One project's going to involve the idea of a sorted map. So it'd be a good idea. And it's an optional project, as all the projects are. You just pick which one you want to use, right? I mean, doing a project is an optional. Anyways, so write a program that associates strings to strings, right? Just kind of like our dictionary up there, our Spanish to English dictionary. Ask the user 3 times for a key and a value. Add each key and value to the tree map. I'm going to need to rewrite this just a little bit. Write a program that creates a tree map that associates strings to strings. Print the tree map using a for loop. Ask the user which key to remove. Remove that key. Print the tree map again. Handle the case where if they try to remove a key that doesn't exist, right? Then we indicate that to the user. Print the tree map again. Then we're going to ask the user for a key to display, for a value, the key's value to display. Display that key's value, and you're done. Maybe we should do that before we remove the element from the map. Right? Just because after we remove it, there's only going to be 2 elements in there rather than 3. So they're going to wind up typing in 3 things. So it could look something like this. We will add 3 elements to a tree map. Element 1. Enter the key. And they're going to type in whatever, right? It can be any string. Element 1, enter the value. They type in a value, right? Even if it's a number, it's going to be a string, right? So, you know, hello, whatever. Element 2, enter the key. B, 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 B. Element 2, enter the value. You know, X, Y, Z, Z, Z. Element 3, enter the key. L, M, N, O, B. Element 3, enter the value. You can make this interface look different, of course. You know, 1, 2, 3, 4, 5. So we've just got all there. Now we're going to display, you know, now displaying the tree map. Key A, B, C, D, E. Value hello, right? Key B, 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 B. Value X, Y, Z, Z, Z. You know where I'm getting these values. Right. And then key element OP. Value 1, 2, 3, 4, 5. Which key do you want to remove? They type in element OP. Wait, we forgot to access. Which key do you wish to view? Right. So they type in element OP. The value for element OP is 1, 2, 3, 4, 5. Which key do you wish to remove? They remove element OP. And then now displaying the tree map again. It's going to display everything except for the element OP entry because that has now been removed. All right. So that's what the homework's going to be. Shorter lecture than usual, but that's okay because I think I gave you 3 lectures for this week.